Hey everyone. So we're going to be doing something just a little bit different here for Friday. You're going to watch these two videos. For your homework, you're going to start your notes for homework instead of something on Math Excel. So we can do more problems and do our homework in class. I'm going to try to flip this around and see if I like doing things this way, or maybe if you all like doing it this way too. So get ready. We're going to take some notes on linear equations, stuff I'm hoping that you are familiar with. So let's get going. First of all, slope. I'm hoping you remember the formula. Y2 minus y1 over x2 minus x1. Another way we like to think about this is the change in y over change in x. On the little triangle's Greek delta. We use that, excuse me, in math and science to represent the word change. And then thinking quickly about this little sketch right here, if we think about this point and this point right here. Another way to think about slope, now that you've had some trigonometry, here's our change in x, here's our change in y. If you know the angle right here, slope is going to be tangent of that angle theta. Some quick sketches, stuff I'm expecting that you know. A line with a positive slope is rising. A line with a negative slope we're going to call falling. So that is a negative slope. These ones people sometimes forget. Let's talk about our horizontal and our vertical lines. I know you know what they look like, but what do we know about their slopes? For horizontal, the slope is 0. There is all run, no rise. And then for vertical, since it's all rise and no run, the slope is undefined. Recall that a vertical line is not a function. It doesn't pass the vertical line test. Moving on to stuff I'm sure you are familiar with. Let's talk about our linear forms. We have our slope-intercept form. Y equals mx plus b. Why does it have its name? Because in this form we can readily see the slope and the y-intercept. Then we have point slope form. The more math I did, I always thought point slope form was more important. What does that one look like? Y minus y1 equals m times x minus x1. Again, we see the slope as the name would imply, and we also see a point. So x1 comma y1, that is just some point on the line. A point on the line. So why did I say point slope felt more important? It's because this one's easier to get, because this one requires the specific y-intercept. You have to know that certain point, where this one you can use any point. Standard form. Our ax plus by equals c. If you really need to know anything, a, b, and c are integers, are whole numbers. And then this one you might not be familiar with. General form. It's standard form but it's set equal to 0. So ax plus by plus c equals 0. Now, don't get me wrong. It's not that I subtracted c over. These letters and those letters don't connect with each other. But those are our 4 forms. These 3 I know you're familiar with. Maybe you are familiar with that one. Let's go back to horizontal and vertical lines really quick. When writing their equations, let's say we have this graph, 1, 2, 3, 4, and then let's do a vertical line where we have something over there. If you have a line it goes like this. Its equation is y equals 4. So a horizontal line will always have its equation y equal to some number. We'll call it b because it's the y-intercept. And then let's have our vertical line. The equation for that one is going to be x equals -3. So if you recall, any vertical line will have its equation x equals some number a. So those are some basic facts about our horizontal and vertical lines. We've talked about parallel lines already a little bit. Let's talk about the difference between parallel and perpendicular lines. Parallel lines, two non-vertical lines that do not intersect. We talked about this part, same slope, different y-intercept. That's going to make them go in the same direction, but they start in different places, so they'll never touch. Perpendicular, I'm hoping you remember, slopes are opposite reciprocals. And that's basically what you need to know. A specific thing you could know is that vertical and horizontal lines are perpendicular. And if you remember our symbol for perpendicular, kind of like an upside down T. So an example of this, if the slope of a line is 2/3, something perpendicular to it, you take the opposite negative, reciprocal, you flip it over, -3/2. All right, to finish up with these notes, which is probably going to take like 4 more minutes or so, we have 6 problems that we're going to write the equation of a line. Maybe I'll save some for class. Maybe I'll get through all of them. I haven't quite decided. So, some problems. Write the equation. We'll start with the easy ones. If I were to tell you that m equals 7 and the y-intercept is -3, my hope is that you jump right to y equals 7x minus 3. Let's look at the next one. What if I told you that the slope was -4/7 and the line goes through the point -2, 5? Well, in this case, you have slope, you have a point. Let's use point-slope form. Y minus the y-coordinate equals the slope times x minus the x-coordinate, but you notice the x-coordinate is negative, so why not flip the sign so that it is positive. The third one, let's say it passes through these 2 points, -8, -2, and 5, -2. Well, we're not given a slope this time. You have to calculate the slope. So let's do that. Over 5 minus -8. Looks like we get 0/13. The slope is 0. What does that line look like? Y equals some number, and how can we tell what the number is? Look at that thing that's the same for both points. It's actually going to be the same. For all points, there is our equation for that one. Let's run through the last couple. For these, it might be a nice idea to pause after I write down the problem and try them yourself. Those other 3, very easy. I figured you would know how to do that, and I guess I shouldn't say easy because if you're having trouble, that's not a problem, but just something to remember. You definitely have done this before. So number 4, let's find the line that contains the point 7,3 and is parallel to 3x plus 4y equals 24. We have a point, we need a slope. So one thing I tell my Algebra 1 students, this thing in front of the x is not the slope until the y is by itself. So if we were to rewrite this, hopefully you're okay with me kind of skipping some steps for writing. -3/4 x plus 6. There's our slope. Since we're parallel, it's the same. Let's write it in point slope form. Y minus 3 equals negative 3/4. X minus our x coordinate 7. Number 5, we did a parallel problem. Let's do a perpendicular problem. Contains negative 8, 0, and is perpendicular to 7y minus x plus 17 equals 0. So again, we need the slope. It's not going to be the same this time, but we're still going to do something with it. So rewriting this one, 7y equals x minus 17 divided by 7, y equals 1/7 x minus 17/7. Well, there's the slope. Perpendicular, opposite, reciprocal. It's positive. We need a negative. Flip it over. 1/7 flipped over, 7/1. So there is our slope, negative 7. Let's use our point. Let's use point slope form again. Y minus 0 equals negative 7 times x minus negative 8. So let's put plus 8. And we don't really technically need that minus 0, even if we're not going to distribute our negative 7. You can leave it like that. All right, to wrap up, let's actually do something that's a little tricky. So write the equation of a tangent line to the circle with center 3, 2, and passes through 6, 11. Now this one we need a little bit of an explanation if you don't know or don't remember. A tangent line is a line which touches a curve in one place. How can you tell things are going to be tangent? So let me draw this awful circle right here. A tangent line is going to kind of like skip across one point. And how do we figure out how to find the equation of that line? If you draw a radius, you can find the perpendicular slope right there, and that's going to help us find our slope. We know the point it passes through. We just need to figure out what the slope of that line is. And it's got to be perpendicular to the radius, and our radius extends from 3, 2 to 6, 11. Using our slope formula, 9/3. Looks like our slope of the radius is 3. And since the tangent thing kind of skips off of it, needs to be perpendicular, our perpendicular slope is going to be negative 1/3. And finally, using our point, we wrap up this section with our final equation right there. Hints for these videos: you can play them quicker, you can pause them, you can go back. You missed something, I wrote too fast, you can go back, think about it. These are problems and similar problems, these are problems we're going to work with similar ideas in class so that we can practice, but you've seen me do them right now. So you got one more video to watch after this one. Thank you for your 13.5 minutes now. And yeah, well, you'll learn a little bit about parabolas next. See ya.